Hey folks, Segasonicfan here. I'm going to try to keep this one short because this is an easy repair, but it's something that I've talked about before, and I'm thinking I might make a series on it or something of engineering faux pas, engineering snafus, mistakes, whatever you want to call them. It's really sad when you see a really nicely designed product like this, which has a solar panel, some LiPo batteries inside, you know, nice bright LED light. Nothing on the surface seems to be wrong with it. And you certainly don't want to throw this in the dumpster because of the large LiPo batteries. But that's really what happens with these things when they fail. Fortunately, I got this one before it went to the dumpster. But what we have here is this is a replacement on and off switch that broke. I'd like to show you why that broke and how that broke and why it's totally preventable and just bad engineering at play. Because you have this board, which seems reasonably well designed, but one of the things that engineers, you have a kind of a split often between mechanical engineering and electrical engineering, where someone's designing the case and someone else is designing the circuit board, and they're not really taking into account the failures. Like if you were to make, you know, like a diagram of two circles intersecting, there's like a large kind of failure area in between those two disciplines, and as is often the case, that's where failures occur. In this case, you have both people doing their jobs reasonably well, but the mechanical engineer here is designing this to save money, of course. This just kind of slots in and uses an angle trajectory, almost like a 45-degree angle depression to hit the button here at S1, which is this button, of course, which is set at a 90-degree angle. This is horrible. This is really bad. That's why this original button broke. Tactile push buttons are not ever designed to be depressed at weird angles like that. They have a conical disc inside that depresses with a vertical force directly spaced over at equal distance from, you know, at the equal. You want the radius to be equal from the center point. And so they're designed to really be head-on switches. That's, you know, SPSTs, that's all they're meant for. When you start hitting them at angles like this, these really weird angles, what happens is over time you slowly deform that conical disc inside, which is not meant to have pressure applied in a weird angle like that. And so that's exactly what happened. The person, I think, got frustrated too and started jamming things into it and then actually broke the plastic apart completely, like broke out the back by probably jamming some tweezers or something in there. And so it failed. Now, I'm going to put this new button in here and maybe see if I can 3D print a new plastic piece, but it's a little hard. The way it's actually set up really lends itself to this error in design. So what they should have done is, of course, added 2 strain reliefs for this button, one on either side, and then it could push directly on instead of needing this angle here. So not a super like detailed fancy repair here, but just to show you all of this other stuff goes into the e-waste because of that one engineering snafu, faux pas, mistake. If this video is useful or interesting to you, let me know. I like hearing from folks. Other than that, have fun repairing stuff. This is Segasonicfan, signing out.